So congratulations for making it this far. We are in section 3 and now we will start digging more into C. In this section we will talk about advanced topics. And first of all we want to talk about what's called a structure. And by the way, I'm going to keep these videos short and easy. So everything will be clear, don't worry. First of all, let's suppose we want to store some information about people, okay? And each person has a name and an age. So let's suppose we have 10 people and we want to store the name and the age of each one. So with the information that we know up until this point, we would do something like this. Let's make a name, and this name will be the name of the first person. Let's say it is maximum 10 characters. Then we will make another name for the second person. Now, regarding the age, we will make a double age 1 for the first person, initialize it to 0, and a double age 2 for the second person, also initialize it to 0. So as you can see, we are making two variables for each person, the name and the age. So if we have 10 people, we would have 20 variables. And imagine a code with the 20 variables only to keep track of some information for people. So as you can see, this is a big problem. So here is where a structure comes in. A structure allows us to define our own data type. So for example, this over here is a character, this over here is a double. We will be able to define our own data type. For example, we will call it person. And in this data type, we will put some members or fields or attributes. These attributes will be the name and the age. The name will be a string and the age will be a double. And when we have our data type, which is called person, we will make variables of type person. And this will make things much easier and it will make our code much cleaner. So let's define our structure person. First of all, start by typing the keyword struct. Then put the name of the structure or the data type. So we put person. And as you can see, I'm naming it with a capital letter and it is a convention, okay? Now after that we put some braces. And as you can see, it automatically puts a semicolon. So after the definition of a structure, we should put a semicolon. Now inside these braces, we will put our members. As we said, we have a member which is a string and a member which is a double. So we will have something like this. Char name, let's say it has maximum 10 characters and a double age. Now over here, we cannot initialize variables, okay? So we just define them as you can see. And after each member, we should put a semicolon. So members are separated with semicolons as you can see. And also the last member, we should end it with a semicolon. Now we have our data type. All we have to do is to make a variable of this type. So the type over here is struct person, okay? So I will type here struct person. Then put the name of the variable. So let's say this will be P1, which means person 1. So simply I'm putting the type and the variable name, okay? So for example, if we have an integer, we put int x, for example. Now we are putting struct person and the name of the variable is P1. Now this P1 has his own name and age. Now to access the members, we use the dot operator. So type P1, then put dot. And over here, we have to put the name of the member that we want to access. So let's suppose I want to access this variable, age. So I type age. Now, this over here, you can consider it this variable, age. So we can do something like this, equals 20. Okay? Now let's printf %lf and let's print p1.age. Build and run the program. And as you can see, we have 20 perfectly. So we accessed the age property of our P1. Now, let's remove this printf and let's access this name. So I'll do something like this. For int I equals 0, I is less than 10, I++. Over here, I want to access the array name and I want to print name sub I. Okay? So let's take this and put printf %c and I want to print p1.name sub I. So this is my person 1 and I'm accessing the elements of this array and I'm printing them. Build and run the program. As you can see, we have this garbage, okay? Now, let's put some value inside this string. We know that to put a value inside a string, we use the strcopy function. So strcopy, and over here we should give the destination and the source. So the destination is p1.name, okay? Why is this? We know that this over here is the address of the array or the string, and this function should take the address. So simply the address is p1, and we want to access this, the name of our array, which is in this case name. So we put p1.name. So this is the address and this is our destination. Now the source, let's say p1 name, like this, okay? Now we have to modify this loop because over here we have 1, 2, 3, 4, 5, 6, 7 characters. So less than 7, build and run, and as you can see the name is printed. Also we can use the putS function. So let's say putS, and we want to give it the address. So the address in this case is p1.name. Build and run the program, and we have our string printed perfectly. Now let's imagine we want to have a second person. So all we have to do, we type struct person p2. Now this person has also his own name and his own age. So let's say p2.age is equal to 30, and strcopy, we want to copy to our p2.name something like p2 name. Now over here let's put as p2.name, okay? So just like we did over here, but now we are doing it with a second person. Build and run the program, as you can see p1 name and p2 name. So all this ugly stuff over here, we got rid of it, and now we have this beautiful structure where we can make independent variables that have the members that we want, okay? So what I want you to take from this video, a structure is a data type that we define. It has some members, and these members can be of any type that we learned previously. To access these members, we use the dot operator, and when we access them, we use them just like any other variables. So this age, we are assigning it to a value. This name, we are using the address, and also we can access it inside a loop just like a normal array. And if we have more members over here, we can access them in the same way. So a structure is very simple, and we will do a lot of exercises to make you a pro in structures. So this is it for this video, and I'll see you in the next one. So this is the same code from the previous video, and now we will take a look at these points over here. First of all, I want to tell you something about structure assignment. So for example, let's say we have this p2 over here. We can make the following. We can assign p2 to be equal to p1, and this automatically assigns the name of p2 to be equal to the name of p1, and the age of p2 to be equal to the age of p1. So let's over here printf %lf \n p2.age. So we should see 20, and over here whenever we print the name of p2, we should see p1 name, right? So build and run the program. As you can see, p1 name, this is the name of p1 over here. Now we have 20. This printf, this is the age of p2, which is equal to the age of p1. And whenever we print the name of p2, we can see also p1 name. So you can assign structures normally like any other variables. Now let's suppose I want to compare p1 and p2. So now we are talking about this point over here. So let's printf %d, and I want to see if p2 is equal to p1. Build and run the program, and we have an error. Open the logs and see this. Invalid operands to binary operator equals struct person and struct person. So what this means basically is that what we have on this side of the equal and what we have on this side of the equal is not compatible with the equal. So we cannot compare structures like any other variables, okay? Now if you are asking how would we compare structures, basically we would make a function that takes two structures, and we will see if all the members of these structures are equal. So if they are, we will return 1, and if they are not, we will return 0. It's so simple, and we will solve it later on. But now what I want you to know is that we cannot use equal, just this. Now I will remove p2, also remove everything over here, and let's also remove this. Now this is our code. We have p1, which is a person. Now let's see the size of our structure. So printf %d size of, and over here we can put a data type, right? So we can normally type struct person like this. Build and run the program, and as you can see we have 24. So this structure, whenever we define a variable of this type, this variable will take 24 bytes in our memory. Now let's see the size of p1. So let's print size of p1. Build and run. As you can see, it is 24. Now let's see the size of p1.name. So basically we are seeing the size of this array over here. We are giving the name of the array. Build and run. We can see 10. So this array is an array of characters and it has 10 characters. And since each character takes 1 byte in the memory, we see 10 over here. Now let's see the size of p1.age. Build and run, and we see 8. So a double takes 8 bytes in the memory. So 10 plus 8 gives us 18. It does not give us 24. And the size of this structure is 24 bytes. So what I want you to know is that the size of a structure can be greater than the sum of the size of its members, okay? Just this. Now I will remove this printf, and over here as you can see we are making p1, which is a person. It would be better if we only type person and we don't type struct person, right? So we can use what's called typedef. This is a keyword. So this keyword, we put the current data type name and the new data type name. So for example, if we do something like this, typedef, then let's say int, and let's say hello. So now if I make hello x, x is an integer. So printf %d, and we print x, and let's put some value, so 20. Build and run the program, and as you can see we have 20. And by the way, type hello, and as you can see we have some information. So typedef and int hello, yes? So we will use this typedef to change the name of our structure. So the current name is struct person, and the new name, let's say we want it to be person like this, and I typed it with a small p because it's easier to type, okay? So build and run the program. As you can see everything is still working. So we can still use struct person, but also we can use this person over here. So person p1, and now let's for example printf %d and print the size of p1. So we should see 24. Build and run, and we have 24 perfectly. Now we can use this typedef with structures in a different way. So take this keyword and put it before the definition of a structure, and take the name and put it after the brace. So remove this code, and now we have the same thing. So we are defining the structure and we are naming it person, okay? Build and run, and we still see 24. So from now on, every time we make a structure, we will use the typedef in order to give this structure a name, and we will use this name in order to define variables that has the type of this structure. So this is it for this video, and I'll see you in the next one. So we have the struct person over here, and I want to tell you one thing. We can omit or remove the name of the structure. So we can have it like this. And now we can make variables of this type using the person, because we are using typedef. So if we removed the typedef, so let me comment this code, build and run the program. As you can see everything is working perfectly. But we can't make variables for this structure in this way over here. We can't declare them. There is a way to make some variables. It's not important, and everything I'm saying right now is not important, but I want you to know this. So whenever you make a structure in this way, over here, the names that you put over here are variables of this structure. So let's say we put p1 and p2, okay? Now p1 and p2 are variables of this structure over here. So let's for example printf two integers, and these integers are the size of p1 and the size of p2. And by the way, I'm not putting parentheses because these are variables, and with variables we can remove the parentheses. So build and run the program. As you see we have 24 and 24. So as I said, this is not important, but I just want you to know this. Now let's give this structure a name. So let's call it person, and we have to use the typedef. So if you don't use the typedef and you put a name over here, this name would be a variable of type this structure. And whenever you put typedef, this name over here will be the name of this structure, okay? Let's now get to the point of this video, where we will see how we can initialize the variables of a structure. So we have this variable p1 over here, and simply I'm printing a string and a double. The string is the name of p1 and the double is the age of p1. Okay, so build and run this program. As you see, in our name we have some garbage and our age is equal to 0. So now let's see how we can initialize these variables. First of all, let's put over here equal empty braces, and this will initialize all the variables to their default value. So build and run the program. Now we have our name is empty and age is also equal to 0. But from a little bit, age was not initialized. It was an accident that age was equal to 0. So for example, let me show you this. Change this to be an integer, and over here we will print %d. We are initializing the variables, so build and run. So we see an empty string and age is equal to 0. So our variable integer was initialized to 0. Now let's remove this initialization, build and run. And as you see, we have this garbage over here, and also our integer is not equal to 0. So it is not initialized. So to initialize all the variables to the default values, we put empty braces. The default value for a string is an empty string, which means a \0, and the default value for numbers is 0. So let's verify that this string is being initialized to an empty string. So I'm going to print another integer, and this integer will be something like this: p1.name, and I will access the first element is equal to \0. So if this is true, our string will be an empty string, right? Build and run the program, and as you can see, we have 1. So this condition is true, so the default value of a string is an empty string. Now let's say I want to initialize the first variable. So the first value that I put between these braces will initialize the first variable over here. In this case we have a string, so let's give it something like this. This is a string. Now build and run the program. As you can see, our string is initialized to this value, and our age is initialized to its default value. So whenever we initialize a variable and we don't initialize the other variables will be initialized to their default value. Okay, and this 0 over here is because the first letter is not \0. We don't care about it anymore. Okay, let's remove this and also remove this, and now let's initialize our age. So put a comma just like you initialize arrays, and now let's initialize age to be equal to 20, for example. Build and run the program. Now we have this string and we have this age. Perfect. Now the order of these values is important, because the first one initializes the first member and the second one initializes the second member. And if we have more members, we can initialize them by putting commas. Okay, so let's suppose I want to initialize my age first, and then I want to initialize my string. Then we cannot do something like this. So if we do something like this, we would not get a correct answer, because we are initializing the string to be equal to 20 and the integer to be equal to this string. Build and run, and as you can see, we have this weird output. So to be able to do this, over here put dot, and now put the name of the member that you want to initialize. So in this case we want to initialize age to be equal to 20, and over here we want to initialize our string to be equal to this string over here. So we put dot name equals, and we have this string, and now we are initializing this string to our member that is called name, and we are initializing this integer to our member that is called age. Build and run, and as you can see, this is our string and this is our integer. So perfect. So this is how we initialize variables of a structure type. And I want to say one thing: later on we will make functions to initialize our structures. Okay, so we may use this method sometimes, but other times we will use functions. So this is it for this video, and I'll see you in the next one. So we have this code over here, and we have this person p1. Now we're going to have a look at the addresses. So the address of a structure, simply we put the address of the variable. Okay, now the address of the name member, so this one over here, it is an array, right? So all you have to do is to access the structure and get the name of the array. So it would be something like this, right? Now the address of the variable age, first of all let's access the variable like this, and then we put the and sign. And also we can do it in another way, so put parentheses and surround p1.age and put the address. So if this is more clear to you, you can use it. Now let's build and run the program. As you can see, this is the address of our structure. This is the address of our string, and this is the address of our age. Now, have a look. The address of our age is equal to the address of our structure. This is because age is the first member. So, let's for example put the string at first. Build and run the program. Now, if you have a look, the address of the structure is equal to the address of the string. So, the address of the structure is the address of its first element. Similar to the arrays, where the address of the array is the address of the first element, okay? So actually, this is it for this video, and I'll see you on the next one. So we have this structure, and now we're going to make something like this. So let's say I want 3 persons. So I can make an array, let's call it people, and it has 3 elements. And this array is of type person. So let's suppose we are inside a loop. So people sub I is a structure. So people sub 0 is a structure, people sub 1 is a structure, and people sub 2 is a structure. And we can access the members of these structures. Now let I, for example, equal 0. So to access the members of people sub 0, we will make something like this. So people sub I dot name, this will access the string. And also people sub I dot age will access the age, right? So now let's fill this array. So iterate over all of its elements. Int I equals 0, I is less than 3, and I plus plus. So in here, let's printf something like this. Enter name, okay? And now we want to take the name. So since this is a string, let's use the function getS. And over here, we will give it the address of the string that we want to fill. So first of all, let's get our elements. So people sub I. Now we want to access the address of the string. So dot name. Now for I equals 0, this function over here takes people sub 0 dot name. So we are filling the name of the first person. Then I plus plus people sub 1 dot name, the second person. And then we will fill the name of the third person. Now also we want to take the age, something like this. Enter age, and now we want to read the age. So scanf %lf, and we want to store the value inside the age of each person. So people sub I dot age. So this loop over here iterates over all the elements where each element is a structure, and we are reading the name of this structure and the age. Now let's make another loop that iterates over the elements and prints them, okay? We have the same thing, but over here let's say printf, and want to print the name, so %s, and want to print the age, so %lf. The name is people sub I dot name. Now the age is people sub I dot age, right? Now each time we print a person, let's put \n. So let's remove the braces, and now build and run the program. So enter name. Now it's better to see something like this. So enter name 1, enter name 2, etc. So let's put over here a variable %d, and this variable would be something like this, I plus 1. So when I is equal to 0, enter name 1. When I is equal to 1, enter name 2, and so on. And we'll do the same thing over here. So enter age %d and I plus 1. Build and run the program. So enter name 1. Let's say name 1 is AA. Now press enter. Enter age 1. So let's say age 1 is 11. Now as you can see, when I press enter name 2 executes, and then we have enter age 2. We saw this previously when we used the scanf to read a character. The problem was that \n is in our buffer, and the input is reading the \n. So getS over here, whenever we enter 11 and press enter, it is reading the \n. So to fix this, we will use our fflush function. So before using getS, we want to flush or empty our input. So fflush like this, and it takes the standard input, so stdn. Now run the program again. Enter name 1, AA, enter age 1, 11. As you can see, now we are reading the second name. So let me go over this. First of all, I is equal to 0. So we are reading people 0 dot name. So this is the first person dot name. So his name is AA. And then we are reading a double, and we are storing it inside people sub 0 dot age. So this is the age of the first person. His age is 11. So now we make I plus plus, and now I is equal to 1. So we will do the same thing with the second person. So let's say his name is BB and his age is 22. The third person CC 33. Press enter, And now this loop finishes executing and this loop is executing over here. So we are printing the elements of our array people sub I.name, people sub I.age. So for I equals 0 we see this, and this is our first person. For I equal 1 we see this, and for I equal 2 we see this. So now we know how to make an array of structures and work with it. So this is it for this video, and I'll see you in the next one. So this is the same code from the previous video, and now we want to make a function that takes an array of persons and fills it. So basically we are turning this code into a function. So the type of this function is going to be void, and let's call it fill array. So this function should take an array that has the type person. So person array, and we want to give the size, so int n. Now basically in this function we will have similar to this code. So let me put this code over here. So I equals 0, I is less than n, and we have to change the name of our array. So over here we have array, and over here we have array, and everything else is the same. Now let me show you this. Try to build and run the program and you have an error. So as you can see, unknown type name, which is person. So this person at this point over here is not known, and this is because we are declaring our structure inside the main function. Let me show you another example. I'm going to try to make a person P2 above the structure, or let's call it P1. It doesn't matter. So now let me comment this code, try to build another program, and also over here we have unknown type name person. So in order to use this structure, we can only use it after we define it. So to be able to use this structure over here, we have to define it globally. So let's take this code and put it at the top. Now let's remove this comment. Let's organize the code like this. Now try to build the program, and as you can see we have no errors. Open the logs. We only have this warning that this variable over here, person P1, is not used. So we don't care about this. Now let me remove person P1 and let's organize the code. Perfect. Now since we have this structure defined globally, we can use it everywhere. So over here this structure is accessible, so everything will work just fine. Now let's make another function to print a structure. So void print array. It takes an array of persons and also will take the size, and in here we will say something like this. Let me cut this code and put it inside this function. Now the name of our array is array, so over here we have array and over here we have array, and the size is n, so I will be less than n. Perfect. Now let me change this to have 2 persons only, and let's try our functions. So fill array, we will give it our array people and the size is equal to 2. Then I want to print them, so print array, I will also give it people and 2. Build and run the program. Enter name 1, let's say A, enter age 1, enter name 2, let's say B, and age is 2. So this over here is our fill array function, and this over here is our print array function. So the idea behind this exercise is to define the structure globally. And most of the time, whenever we make structures, we will define them globally in order to use them in all our program. So this is it for this video, and I'll see you in the next one. So in this video, we will define 2 structures, a student structure and a courses structure. Let's start with the student structure. So typedef, and we want to make a struct. I don't want to give it a name because I'm using typedef, and I will call it std, short for student. Now in this structure I want to store the student name, so I'm going to suppose it is maximum 10 characters. Also let's store the student age, and now over here we want to store information about the courses of the student, and as I said we want to make a structure of courses, so let's define that before we continue. So typedef, also want to make a struct, and this struct will be called course. In this struct we will have something like this. I'm going to have the name of the course, so also name, suppose it is maximum 10 characters, and also I want a double to store the grade on this course, so grade. Now over here this student, let's say he has 2 courses, so I can make an array that has 2 elements of this type, right? So course, and let's call it courses. This is our array and it has 2 elements. So the idea behind what we are doing over here is to see that we are able to use a struct inside another struct. So now let's go to our main and make a student. So std s1. Now s1 dot. As you can see, when I press dot, I see the members. So I have the age, I have the name, and I have the courses. So press on the courses. Now this over here is an array. Let's access the first element of the array. And as we already know, each element of this array is a structure of type course. So let's put dot again, and as you can see, now we access the members of the course, the grade and the name. So let's assume that the name of the first course is mathematics. So we are going to use our strcopy function and put mathematics. So something like this, strcopy, and put semicolon. Perfect. Now let's print the name of this course. So over here, copy this and put it here. So I'm accessing my student, I'm accessing the array of courses, and I'm getting the address of the name of the course. So this over here should display math. Put a semicolon, build and run the program, and as you can see we have math. Perfect. Remove this code, and now let's do something like this. So printf, enter your name, and now we want to read the name of the student. So let's use getAs, and over here we have to give the address of the name of the student. So s1.name. Perfect. Now let's printf, enter your age. So we want to use scanf, we read a double, and we store it inside s1.age, and we have to give the address. Perfect. Now let's printf, enter course name, like this, and also enter course grade. Okay, and as you know we have two courses, so let's use a loop to iterate over these two courses. So for int I equals 0, I is less than 2, and I plus plus. Let me remove this code, put some braces, and inside this loop we will read the name and the grade of each course. So first of all, enter course, let's print an integer over here, and it will be I plus 1. So enter course 1 name, enter course 2 name, etc. And over here we will have the same thing. Okay. Now we want to read the name of the first course. So I'm going to use getAs because it is a string, and I want to give it the address of the first course. So s1.courses sub0.name. This is the first course, but we are inside a loop, so I will put over here I. So when I is equal to 0, over here we are getting the name of the first course. When I is equal to 1, we are getting the name of the second course. Now let's get the grade. So we want to use scanf %lf because the grade is a double. Let's access the student, let's access the array of courses, so courses sub I, and we want to fill the grade. Of course we have to give the address, so over here we have address. Perfect. So when we finish executing this loop, we should fill the name of both courses and the grades on both courses. Let's do the following. Printf, we will print the name of the student, so %s, and his age, so %lf. The name of the student is s1.name, his age is s1.age. Perfect. Let's put now \n. Let me add some more spaces. Okay, this is better. And now let's print something like this. So printf courses. So we will list all the courses and the grades of this student. So we want to iterate over the courses, so I'm going to use the same loop over here. And now I will print the name and the grade on each course. So the name of the course is a string, the grade is a double, and each time I print a course I will go to a new line. So I want to print s1.courses sub I.name, and the second thing I want to print is the grade, so s1.courses sub I.grade. Perfect. Now let's organize the code. Okay, and now build and run the program. So first of all we have a student, and now we are reading the student name, s1.name. So this member over here. So let's say the name is s1. Press enter. Now we are reading the age. So s1.age. So this member over here. So let's say he is 20 years old. Now as you can see, we also have a problem with getAs. When we are pressing enter, getAs is reading the \n. So let's fix this. Over here, before using getAs, we want to flush standard input, right? So build and run again, s1 20. Perfect. So let's say the first course is programming, and he got 10 on programming. Now the second course is mathematics, and he got also 10. Now this loop has finished executing. We are printing the name and the age. We can see S1 20, perfect. And then we are printing the courses. So courses, this printf over here, and now we are looping over the courses. We are printing the name and the grade. So programming 10 and mathematics 10, perfect. So let me go over this loop and we will end this video. So I is equal to 0, I is less than 2, I++. We printed this message, so enter course 1 name. And now we flushed the input, and now we are reading this string. S1, we are accessing courses sub-0 and giving the address of the string. So this programming will be stored inside the name of the first course. Then we printed this message, enter course 1 grade. And we are storing the value inside S1, access courses sub-0, so the first course, and we store the value inside this member, the grade. So we entered 10. Perfect. We have here programming and 10. Now I++, so we do the same thing with the second course. And in this loop, we are iterating over the courses. So first time we print the name of courses sub-0, and then we print the grade of courses sub-0. And then the name and the grade of courses sub-1. Perfect. So what I want you to take from this video is that we can have a structure inside another structure. And to access the members, we use the dot operator normally, okay? So this over here is a structure, so to access the member, we put dot. Perfect. This is it for this video, and I'll see you in the next one.